Hey, Algebra 1. So yesterday we talked about these problems up here. We used several examples looking at the quadratic formula. And so what we're going to do today is we are only going to see some more examples. So if you did not have enough time or you spent a whole lot of time yesterday, because I realized that it was a half an hour video and then, 4 problems, and I can't imagine that took less than maybe 45 minutes. Not the 4 problems by themselves, but altogether. And so I want to be conscious of your time. So what we're going to do today, we are going to look at the 3 parabolas from yesterday, and we are going to relate them back to using the quadratic formula here. And so what things look like when they have 2 irrational roots, what things look like when they don't have any intersections. And so that's what we're going to look at here, and what it looks like whenever there is one solution. And then tomorrow we will talk about graphing. Thursday we'll wrap that up. And then after May 1st, we will have extension activities provided on Google Classroom that deal with problem solving, interpreting graphs, and other stuff that will prepare you for specifically Algebra 2. I know next year you're going into geometry, but I don't know, these topics come back up a lot more in Algebra 2 than they do in geometry. So here we go. So I have copied the quadratic formula here again, and in Desmos, we don't have to type in equals 0, because if we do, then it makes everything kind of weird. And so this is the equation y equals x squared minus 3x minus 5. And where this equals 0 is where the y value is 0. And so if we were to write that y equals x squared minus 3x minus 5, and we wanted to know when the elevation would be 0, then that would be 0 equals x squared minus 3x minus 5. And so that's where we get this whole solving thing from, determining what the roots, solutions, or zeros are on a parabola. And we'll talk a lot more about that when we look at the graphs. So looking at this, we do have a b term, and it's -3. And so -3 is +3 plus or minus 9, because -3 squared is 9, positive. A is 1, so I'm just going to get rid of that. And C is -5. And then again, A is just 1, and so in this case I can just knock that off. And again, I'm going to copy paste that because, oh, dang, that didn't work. Okay. Again, I'm going to copy and paste it because that makes this go a lot more smoothly. So 9 minus 4, -4 times -5 is +20. So that means 9 plus 20. And that is not a perfect square. That is actually 29, and 29 is not a perfect square. So we have 3 plus the square root of 29 divided by 2, and 3 minus the square root of 29. Sorry, 3 minus the square root of 29 divided by 2. And the square root of 29 is about 5.39. So, oh dear. So this would be 3 plus approximately 5.39, and divided by 2, and then 3 minus that. And so I'm just going to put that in my calculator here on my phone. And my first number is 4.195, which is, if you recall, what we what we determined this to be yesterday whenever we looked at Desmos. And so that's this point over here. There is another point at which this crosses, and I can't zoom in on this because it's just a screenshot, but it's going to be fairly close to 0. So let's see. 3 minus 5.39. Said minus, not divided by. Dang. And divide that by 2 is negative 0.195. Okay. Oh, dang, I was missing that. Sorry. It's over here. I guess I just looked at the wrong horizontal bar there. My bad. So yeah, here it's just past -1, and here it is just past +4. And so that is what these two values mean. Now, over here, we can tell from the graph that we are not going to get a solution. And so we know that this is going to be no solution, but what does that look like mathematically? Because whenever you're solving these equations, you got to know what it means whenever you run into specific patterns. So like over here, we knew that this was going to be an irrational number when we saw that this was the square root of 29. The square root of 29 is irrational. It doesn't have a nice square root. So that's how we knew that this was going to be an irrational set of solutions. Over here, what's it going to look like when there is not a solution? And so that's what we're going to look at. So negative b, that means the opposite of +2, which is -2. And then 4 squared, I'm sorry, not 4 squared, 2 squared is 4, minus 4 times 1 times 3. Oh, I guess I need to put my parentheses in there. Okay. And then all over 2a, and again, a is 1 in this case, so we don't have to do anything with that. All right, so here we see, oh dear, that didn't work. Didn't work either. There we go. There we go. 4 times 3, so -4 times +3, that's going to be -12. And 4 minus 12 is -8. And so, here we go. -8. Okay. So now, what is the square root of -8? Well, if you put that into your calculator, you know what? Let me put that in here so that you can. There we go. So that you can see the square root. Where's my square root button on here? How am I so bad at seeing everything? Are you kidding? Guys, help me out. You can't help me because you can't talk to me through the computer. Well. Oh, it's because I'm using a trig calculator? No? Okay, no, you know what? I'm going to go. This is horrible. Okay. Obviously I can't see the square root button there because I'm incredibly blind. So let's try this again. Calculator. There we go. All right. So let's find the square root of -8. And let's see what that says. Error. So my phone says not a number because what number times itself will give you negative? Well, -2 times 2 is -4. So the square root of -4 could be -2 and 2, right? Well, -2 and 2 are two different numbers. So that's why there can't be a square root of a negative number. And so when we see that we call this the discriminant, you'll talk about that in Algebra 2 a lot, but when you see this number under the square root is a negative, that is when we know that this cannot have a real solution. And so in Algebra 2, you'll get to imaginary numbers and talking about I, and it's really cool, but that's not what we're going to get into today. This is just no solution. Gosh, I can't spell. And that is because there is a negative under the square root. Okay? That means that there's nowhere that this is going to touch the x-axis. Okay. All right. Last one then, we're going to look at this. When is there going to be only one solution? What would this look like if there's only one solution? So the b value here is negative 12.6. So that's going to be positive 12.6. And 12.6 quantity squared. Well, I guess I need my calculator again. 12.6 squared. Okay. And now I have to do everything. There we go. 12.6 squared. All right, is 158.76. Yeah, I picked some great numbers here, guys. But you know, we have these calculators and there's nothing really to be scared of about big numbers like this. So A is still positive 1, and C in this case is 3969. And there we go. And A again is just 1, so I can get rid of that. All right, so aside from this looking really scary, there is nothing wrong with it because it's all calculator work, and so no big deal. There we go. And so in my calculator, I'm going to write 158.76 minus 4 parentheses 3969. Is that right? Yep. Okay. Okay. And when I do that, I get 0 because 4 times 3969 is 158.76. And so what is happening here is that, let's see, 158.76, there we go. And so that means that all of this cancels out and the square root of 0 is nothing. And so what that means is 12.6 plus or minus nothing divided by 2, which is 6.3. And so when this under the radical is a 0, you will have only one root, one solution, one answer, one x value. When it's a negative number, no solutions. Whenever it's a non-perfect square, you're going to have two irrational numbers. Whenever it is a perfect square, you'll have nicer numbers. Maybe there'll be a decimal, a rational decimal instead of an irrational one. But that's really the kind of patterns that we see with these trinomials. So there is no assignment for you today. It was really just watch the video. So I guess I have to make sure that you watched the video. So write a comment in the private comment area about something, I don't know, something that you like about these videos or something that you wish would be different, I guess, even though we're in our last week of hardcore new stuff. And then it's just going to be problem solving next week, or the next couple of weeks. But yeah, so in order for you to get the grade today, you have to write a comment about something that you have enjoyed or something that you would like to see different on videos like this. Okay, thanks guys, and we'll see you tomorrow.